Hi, and welcome to Web3 Unfiltered, where we go beyond hype to examine how systems actually work, from infrastructure and incentives to the deeper mechanics shaping decentralized technologies. I am your host, Collins Victory Odabi. Now, there's this growing narrative, this growing assumption that AI is becoming intelligent, that models improve, systems become more reliable, more accurate, more capable of making decisions. That assumption is misleading because AI doesn't understand anything. It actually predicts. It generates output based on probability, not certainty. And that distinction matters because once you place probabilistic systems inside environments that require precision, accountability, and trust, something starts to break. Not always immediately, but inevitably under pressure. My guest today works directly at that intersection. Jason Hart is a marketing, data, analytics, and AI expert, a multi-time SaaS founder and analytics engineer who builds and audits the decision systems companies rely on. He's the founder of Domain Methods, where he works with SaaS and e-commerce companies on revenue data, pipeline architecture, and separating real AI value from noise. He operates in production environments, not theory, building systems, debugging failures, and applying AI where it actually has to work. With two startup exits and a strong track record across data, product, and growth, he brings a grounded, skeptical view of AI that cuts through hype and focuses on what holds up under pressure. Jason, welcome to Web3 Unfiltered. How are you doing today?
Thanks, Colin. Great to be here. Really excited to talk about reliability in the age of AI.
Amazing. Jason, it's great to have you here. So, Jason, first up, I'd like to ask my guests to talk a bit about themselves. So, very briefly, Jason, tell us about you. What is your story and how did you get involved in what you're doing today?
Sure, yeah. I like to refer to myself as a technologist. I have background in IT, marketing, sales, startups, AI, data, all of these different fields. Where they intersect is where I like to hang out and where I feel I bring the most value because I can translate between those audiences and work across those silos. I've spent the last 4 years or so really getting intimate with large language models and generative AI in general, and have quite a few opinions about how we make them more reliable and the systems that we can engineer to ensure or hedge that reliability.
Amazing, Jason. Really, really amazing. Now, Jason, let's start at the roots of the confusion. Most people experience AI through outputs. They see results that feel coherent and useful, and from that, they infer intelligence. That assumption shapes everything that follows after. How systems are deployed, how decisions are made, and how much trust is placed in the outputs. But if that initial assumption is wrong, everything built on top of it becomes fragile. So before we talk about systems, failures, or architecture or infrastructure, we need to establish what AI actually is, not what it appears to be. So Jason, at a fundamental level, let's strip away the noise and the jargon and the hype. What is AI actually doing when it produces an output?
Sure. So, especially in the age of generative AI, we're dealing with statistics, and specifically the statistics of the predicting the next word or the next token or the next character or the next output. And in those statistics, we are establishing a set of probabilities that, given these inputs or the prior words prior to this point, what is the most likely next token or word or next character or next output given those inputs? And as we know in statistics, it's not a 100% probability of the next token or the next word being something specific, something that we would consider deterministic. It's a set of possibilities that each have a different probability of occurring next. And whenever we're generating an output with AI, and specifically generative AI and large language models, there's never just one word or one character or one token that is going to be the right answer, the quote unquote the right answer. There is a set of possible choices. And as we predict the next word, as we predict the next token, we get another set of probabilities that one of those possibilities is what the large language model picks and gives back to us as the answer, and so on and so forth until the end of the generation is satisfied. So when we are getting probabilities instead of very specific outputs, like in a deterministic system, then every time you make a generation, you're going to get a slightly different result. Even if you're very specific, even if you use the same inputs every single time you run the large language model, you're going to get a slightly different output. And the output that you get after that output is going to be slightly different too, because it's based on the prior output that you received. And so whenever you're dealing with probabilistic systems, which is what we're describing here, you are having to navigate a system where it's never black or white. It's shades of gray, and shades of gray based on the probabilities that this is the correct output for the inputs that you provided it. And so you need to mitigate, you need to ensure that if you get a really good output one time, that you execute that same set of inputs with the same prompt, with the same model, with the same harness to ensure that you get a good answer most of the time coming out of that system. Not just once, not just 5 times, maybe not even just 10 times. But if you're expecting this system to run reliably, that ultimately translates into that those outputs are aligned and are accurate given what your expectations are.
Amazing, Jason. Thanks so much for breaking that down. And I think we understand here that once the foundation is clear, the next issue is expectation. If AI is probabilistic, just as you've outlined or highlighted just now, then its outputs are inherently uncertain, even when they appear confident. But most users and organizations don't operate with that in mind. They treat outputs as if they are stable, repeatable, and dependable. But then, even just like you said, when you enter the same prompt over and over again, you get different responses or different outputs. Now, that mismatch between how AI works and how it's used is where risk begin to build. So, Jason, what do most people get wrong about the reliability of AI systems in practice?
Yeah, I think the biggest error that I see people making in the era of large language models is trying to have one monolithic prompt, one monolithic harness, one monolithic solve for accomplishing a certain set of work or even a single task. They try and create the perfect prompt with the perfect tools and the perfect harness and the perfect context to get something to reliably produce a good output. And I think that monolithic approach to solving things is really missing an opportunity to control the output in a more reliable fashion. And I think, too, you're stacking probabilities on top of one another and hoping that the entire set of probabilities multiplies out to a good outcome. Whereas we know from multiplying many different values together that the space that resulting outcome could land in is quite diverse, is quite sparse in terms of the environment where that lives. I think what I have seen works much better is trying to break a single task or a single piece of work into multiple subtasks and maybe even subtasks. Get it down to the most atomic piece of that task, piece of work of that task, so that there's a limited set of outcomes where something could go wrong. And if you break down that task into the smallest piece of work and then tie those together into a graph type of mechanism or a sequence, if you will, then you can control the outcomes of each one of those subtasks, each one of those sub steps individually, and ultimately arrive at a much more controllable output than if you were to try and stack all of those into a single prompt or a single step and craft the best context and the best prompt and run it with the smartest model. You're still going to end up with a lot more controlled output and be able to steer that a lot better, breaking that down into individual steps instead of one monolithic task.
Amazing, Jason. Thank you so much for breaking that down again. Now, Jason, if reliability is misunderstood at the output level, the problem compounds when AI is embedded into larger systems, because AI doesn't exist in isolation. It gets plugged into workflows, decision engines, and operational pipelines that were originally designed to behave predictably. And that's where we begin to see a much deeper conflict. So, Jason, what actually happens when probabilistic AI systems are integrated into deterministic environments?
Yeah, I think that's a great question, and it's something that I see on a regular basis where people dial in a probabilistic AI centric process and try and replace it or put it inside of a normal automation workflow, which is largely deterministic or has historically been deterministic. And it will work, 80% of the time, 90% of the time, 95% of the time. But again, since large language models and modern generative AI are probabilistic, you're going to have a 1 out of nth times where things don't work as expected. And if you're putting these large language model driven automations into a business system, those are largely unattended systems and are usually expected that they're going to work 100% of the time, or at least 99.99% of the time, and that they're going to be able to work in isolation and disconnected from any kind of human oversight. And they're also going to be able to recover if an outcome is not expected or is erroneous in nature. And I think all of these are not given in modern automation systems, even in more traditional robotic process automation work systems that were built and driven from a rules-based architecture that could be expected that every failure mode would be known at the time of development and would be able to be modeled and mitigated effectively so that you could cover 100% of the problem space, of the error space. And in large language models, that's just not possible. You're always, even if you have the most controlled, most broken down process, individual atomic tasks that are being solved one by one for a greater good, you still have a much larger chance of things going awry because you have a probabilistic outcome that could be anything. And it could be anything that one time out of 100 or one time out of 1,000. And how do you recover from that when these are unattended systems, when these automations are running up in the cloud, or are running in the middle of the night, and someone else is relying on their outcome to do their job or to do their work or to move the ball forward in their job. And that's where reliability is largely an afterthought in these systems, because we're so used to having automation in the form of macros or rules-based systems or other things that once they're debugged, then they can go into production and everything is great. And we might want to improve their performance, but we don't have to worry about them breaking after we've already debugged them, after we've already gone through a cycle of quality assurance. But that's just not the world that we live in when we're employing large language models to live inside of these automation systems.
Well, thank you so much, Jason. Now, that integration part or that integration point is where theory begins to meet reality. I believe in controlled environments, AI looks clean and impressive. But production systems introduce so many different types of constraints. We have messy data, edge cases, latency, and real world consequences. And under these conditions, weaknesses that weren't obvious before it starts, they begin to surface. So, where do AI systems most commonly break once they move from controlled demos into production environments?
Yeah, great question. I think where I see this the most is where the engineers developing these systems, these generative AI automation systems, are developing with their limited understanding of how these systems will be used by the business user, by the end user, the person who is going to be interacting with it. And they might start with test cases, they might start with user stories, as they should in a normal development software lifecycle. But chances are they are not fully read in on how the business is expecting to use these systems or how the business user will be using these systems. And even with the best of intentions, even with the best of documentation, even with the best of training, there's going to be endless edge cases and use cases that were not thought about when the developer was developing these systems. And even if some of these edge cases were captured in that, chances are they're not understood well enough that that the developer is going to create a set of tests or a set of evals or a rigorous quality assurance program before they release it out into the wild, out into production, where it's going to be expected to handle these edge cases without any prior instruction or training, or even measurement on how well it can navigate those types of use cases. So I think that's where I see it the most, is that we're treating these generative AI systems like we would traditional software, whereas we really need to be rethinking the entire software development lifecycle around this probabilistic nature where anything could happen, and we need oversight and reliability engineering to make sure that when the unexpected happens, that we have to control the degradation or retry mechanisms or LLMs as judges to keep things on track when they deviate. And I think a lot of this still is not a solved problem yet. We're still trying to understand what are the best practices in terms of dealing with these messy outputs when we're so used to having very controlled and tested outputs when it goes into production.
Amazing, Jason. Thank you so much. Now, at this point, I think it becomes clear that failures aren't just about the model. AI systems sit on top of data pipelines, and these pipelines determine whether or what the system sees, how it interprets output, and what kind of output it produces. So, if something goes wrong, it's really just an AI problem. It could be a system design problem. So, Jason, how does underlying data infrastructure shape audits or undermine the performance of AI systems?
Yeah, I think this is something that I think a lot about because a lot of companies that I go into and look at their business data and their data warehouses and their hygiene of that data, it's not in a great state usually when I arrive. The governance of that data, the cleanliness, the hygiene of that data is usually in various levels of cleanliness from very bad to okay. And I think along with that, the metadata of that data, the information that's describing what is the data in these tables or in these systems, what does it represent, how is it classified, all of the information that allows you to make sense of the data itself is usually pretty sparse as well. There's not a whole lot of data describing the data. And so given the hygiene, given the lack of governance, given the lack of standards, given that this data lives in different systems and may or may not be easily joinable between those silos or between those systems, means that if you just hook up a large language model based agent, just give it access to your data warehouse or all the different systems, it's going to make a lot of assumptions about what it's seeing in these tables or in these systems of record. Some of those assumptions might be accurate. Other assumptions will probably be wildly off. And each one of those assumptions the large language model is making about that data will color how it interprets what it sees in that data, how it's able to analyze the data and reason about what it's seeing in the data. And if it guesses wrong or makes a wrong assumption, probably makes lots of wrong assumptions, then you're going to get a very confident bad answer out of the large language model, and it's going to be very sure that it's right. But yet it's based on false assumptions, it's based on dirty data, it's based on inconsistent standards and missing key parts of that data to build that assessment. So I think that's really the core of a lot of the problems that I see on a day-to-day basis, is that people's data is not ready for AI. Even if we can build the most reliable AI agent to sit upon it, the data just doesn't have enough context or hygiene or information about what it represents for it to be consumable by AI, reliable or not.
Wow, thank you so much, Jason. Now, from what you said the data of people or the data that's accumulated, most times they're not ready for AI. And I believe once you've recognized that both the model and the data introduce uncertainty, the focus shifts. The goal is no longer to make AI perfect. I believe that's very unrealistic. The goal is to design systems that can manage, contain, and operate within that uncertainty without collapsing. So, Jason, from your experience, what does a well-designed decision system look like when it's built to probabilistic AI reliably?
Yeah, I think what it looks like in practice is having as little ambiguity as possible in the inputs that you're feeding into it. And what I mean by that is no small feat, but what I mean by that is that your standards are enforced, your practices are documented, everyone is aligned in terms of what is a certain piece of data or a metric actually mean, how is it calculated. You don't have your finance department using a different taxonomy and a different set of metrics than sales and marketing is using. You have everyone aligned in terms of the data catalog and where everything sits. And if there's two similar numbers or two different sets of data, which one is ultimately the source of truth and should be relied on for certain calculations, and when should certain information be used over other information. All of that needs to be locked down. All of that, all the people in your business need to be aligned in terms of where they go for certain information, how they consume it. When someone is putting together a spreadsheet or a set of slides, how is that information represented? When you have all those processes written down and documented, and everyone is doing business the same way and producing the same data, and the data lives in reconciled sources of truth, then you can better control your AI systems for quality and reliability, because you have all of that ambiguity, you have all of that potential erroneous inference already locked down. You're not introducing additional probability into the mix by having things that could be this way one day, could be that way another day. So I think that would be the answer in terms of your way out of that unreliability with an AI system, is to make sure that the business itself is as deterministic as possible, which it's never going to be. In a human-based business, you're never going to have absolute everything locked down. And part of being in business is rolling the dice and dealing with the consequences and being able to deal with unforeseen circumstances. But in terms of AI, you want to lock down those probabilities as much as you can by having good, clean documentation, hygiened data, documented processes, understanding of the hard truths of the business, such as your ICP or your personas. How is pipeline calculated? When does someone get credit for an order versus when does someone else get credit for an order? All of those things, they can't live in someone's head. They can't live in the ether of the business. They need to be written down. They need to be reconciled across the business, and the business itself needs some maturity around how it conducts itself so that we can train the AI to mimic that maturity.
So in essence, there needs to be as little ambiguity as possible in the inputs that are fed into the system. And Jason, at this stage, the gap between perception and reality becomes very hard to ignore, because outside of technical circles, the narrative around AI is accelerating. We have autonomous agents, full automation systems that supposedly run themselves. And when you compare that narrative to what actually works in production, there's a clear disconnect. It's a very clear one. And that disconnect is where poor decisions get made. Where do you see hype most clearly divergent from reality in how AI is being deployed today?
Well, I think where you see the most hype is, say, in like these vibe coding narratives, where a lot of people, especially those in companies that are raising money in the AI space, are saying that all white collar jobs are going to go away in the next 2 to 5 years. And I think ultimately that's not a reality that can manifest, if simply for the fact that we don't have enough compute or RAM or cooling or data centers or compute to manifest that. Aside from the realities of that, people cannot create software and deploy it and basically have a SaaS business that they bootstrap over a weekend and take that to market. It doesn't work like that. It probably will never work like that, because there's so much domain knowledge that has to go into making sure that everything is locked down, that everything is secure, that it's not hacked, it's not hackable, that there are means for a user to get support when they're trying to use the system. The system itself has a good user experience, which is human. That's a human measurable trait. That's not something that we can kind of put a measurement system on in terms of, does this feel right or does this feel good to use? So I think in the whole vibe coding, software is dead. I think that's where I see this hype the most. But I also see it in almost every other space where large language models and generative AI is being sold, such as, one of the spaces that you and I share is in digital marketing. I see so much quote unquote AI slop in marketing that it's easily discernible by a human, not easily discernible by another AI, coincidentally. But when you go out to LinkedIn or you go out and you see these places where people are incentivized to contribute or to create, you know almost immediately when someone's using ChatGPT to a fault, because it reads like a non-human. It's not. It doesn't have the same oomph. It doesn't have any integrity, and you immediately discount whatever the message is, no matter how useful it might be, because it's just AI slop, which is basically the modern day equivalent of the spam email message. So I think in a lot of these use cases in vibe coding and in digital marketing, collateral generation, social media posting, I mean, I think we're starting to see it all over the place, where it's a very obvious disconnect between what is being sold to people and what it's actually capable of.
You've given a very, very clear example, very valid points, and yes, I do agree with you. When we see AI content, myself for one, when I see AI content, I immediately know. But then I'm not always quick to dismiss an AI content. I try to read the first few lines, and then if it makes sense, yeah. But then if it's just word for word, if it's just copy and paste, and the user is not trying to adjust anything, then yeah, it's not the user's intelligence. It's just something from an AI. And yeah, sometimes I just dismiss it. Now, with all of this that we've discussed, let's bring them into Web3. Decentralized systems, they are built on predictability, transparency, and verifiability. Now, they rely on the idea that outcomes can be independently checked and trusted without ambiguity. AI introduces a different dynamic. We have outputs that are non-deterministic, behavior that can shift, and decisions that are harder to audit. So the tension becomes structural, not just technical. So, Jason, lastly, before we round up the episode, how should builders, especially in Web3, think about integrating AI into decentralized systems without compromising trust and verifiability?
Yeah, I would say some system of redundancy and diversity needs to mitigate the fact that we're dealing with probabilistic outcomes. You're never going to have a deterministic outcome from a probabilistic system, but you can mitigate and push it in that direction by having redundant systems that are producing, say, the same answer and being run in parallel, and then picking the most consistent answer or the best answer as judged by another diverse LLM. These are, again, still problems being solved, but in terms of the root essence of how we solve them, I do think it's redundancy. I do think it's diversity of answer. I do think it's some form of giving additional structure and scaffolding to ensure that the outputs can be reconciled in a deterministic system.
Thank you so much, Jason. This has been an incredibly grounded session. We've learned a few things, and we understand that AI systems, or AI, doesn't replace systems, rather, it complicates them. It introduces uncertainty into environments that depend on precision. And without strong underlying infrastructure, data validation, and control, that uncertainty scales faster than most people realize. The problem isn't that AI is flawed, that it's often misunderstood, and systems built on misunderstood foundations tend to fail, well, eventually. So, thank you so much, Jason. That wraps up today's episode of Web3 Unfiltered. A big thank you. Before I give this final note, Jason, I usually ask, do you have any final notes for our listeners before we wrap up the episode?
Yeah, I would say if you're not out there tinkering with large language models and generative AI, you're missing out. And I think, especially missing out given that a lot of these providers now are heavily incentivizing using their systems either through Claude Code or through ChatGPT. These subscription based models will not last long term. They're giving away compute at a rate that it costs them to provide it more so than it costs you to consume it. And so if you're not using this time where you're incentivized to experiment, to try these things out and figure out how they work or how they don't work, like we're talking about today, you're missing out. You're going to be behind, and it's going to be much more expensive in the future to catch up to your peers.
You're absolutely spot on, Jason. One needs to catch up, and we need to leverage these tools in order to stay competitive in this ever evolving landscape. So, thank you so much for this incredibly grounded session. Yeah.
Thanks, Carl.
Yeah, that wraps up today's episode of Web3 Unfiltered. A big thank you to Jason Hart for joining us today. Until next time, stay sharp, stay curious, and keep building.